My name is Dele Ogunseto. I'm a professor and chair in public health. And this is our last seminar for presentation for our seminar series this quarter. We begin also next year. This series runs throughout the quarter. And we are privileged to have the best faculty members from around the world, actually, to come visit with us, tell us about their work, and stay for lunch with students and faculty and our friends from the community. This series, the nominations for speakers come from every participant, students, faculty, members of the community can nominate speakers. Just let me know, and we schedule them about a year in advance. We also record the videos and we make it available through the generous contribution of the Office of Extension in our Open Courseware program, and we thank the Dean, Gary Matkin, and Adriana Mestas for helping us make that possible. So if you want to see any of the videos from the last 3 years or so, it's archived on the Open Courseware website, and we typically get people from all over the world asking about the topics that are presented here. Today's seminar is by a distinguished professor here at UC Irvine. He was nominated by Professor Brandon Brown after a news coverage of his work sometime last year. Dr. Ramesh Jain is an entrepreneur, a researcher, and an educator. He's a Donald Brand Professor in Information and Computer Sciences, and he conducts research in event, web, and experiential computing. Before he joined UC Irvine, he was on the faculty at Georgia Tech, at UC San Diego, University of Michigan, Ann Arbor, Wayne State, and Indian Institute of Technology. So he's really been all over the world doing this research. He's a fellow of several of the professional societies in his discipline, including IEEE, and his current research interests are in processing massive number of geospatial heterogeneous data streams for building smart social systems. He's received several awards, he's founded several companies, and we're really privileged that his new interest takes him into the realm of public health, where he's going to tell us today about health persona and societal health. Please join me to welcome Dr. Ramesh Jain.
Yeah, thank you very much, Dave. I'm really delighted to be here to talk about something that I find extremely exciting. I've been involved in this research, particularly this project, for about 3 years now. And I think we are making some very interesting progress in this. But the real interesting thing about the project is its implications for society. And because of that, it's not only interesting from technical perspective, it's also very interesting from social perspective and also from entrepreneurial perspective. Now this is a very ambitious project, so I have several collaborators. Many of them are sitting in the room, but I would particularly like to point to two of them who are sitting in the front row with Dell, Siripen and Lale. And I am pointing to those two because if something doesn't work or there is something wrong with the presentation, it's all because of those two. If anything is good, you can tell me. If anything is bad, you can send them to bed. But in addition to them, there are other collaborators, and as, from time to time I will point out. This is truly a project in which lots of people are working. And I am here to find out whether I can identify some more people who can help us do some exciting things. Okay. So, what is happening currently is you are always hearing something about so-called big data. From computer science or in health or in any area, you cannot talk without big data. So one thing that you start asking yourself is, what are all these big data people doing? They have all this kind of data, they are processing this, but what do they do? They are applying all these machine learning techniques and all this kind of thing. What is the ultimate goal of these things? And when you start analyzing this, look at the Google, look at Amazon, look at Netflix and all these people, what you find is something very, very interesting. And what is that interesting thing? They are all trying to target you. They consider you a customer. They consider that the most important thing in your life is to find out the most relevant advertisement that you should be seeing. Okay? So why is all this data being used to do this? Of course, the other aspect of this is related to NSA, but we will not talk about that because they may stop us here. So this is what is going on. So if we start asking, can we use all this data to really solve some big problems? And that's what I think we'll try to talk today about. That time has come to start sensing certain things. And here is one thing that is very popular. It was invented in 1816. It started becoming popular from 1840. And interestingly enough, from 1940, its form has been more or less in this form. This stethoscope has not changed since 1940. There are very few industries where some device that is so important has been used so long. Okay? So, before we go further, I thought of asking you something simple because many of you are students here. All of you have heard the term cyberspace. Okay? What does cyber mean? What does really cyber mean? Robotics, lot of data, cloud. People started talking about cyberspace. So who invented the term cyber and who started making this thing popular? Okay. Any guess when could that have happened? How old could the term be? Was it at all intended to deal with computer clouds? Okay. Now, it's very interesting. This term was coined by Norbert Wiener in 1940. Okay. And he was talking about something called cybernetics. And that cybernetics was the field where he started defining that, in fact, if you look at the definition of cybernetics that we'll see in the next slide, but he made a very important observation. And that observation was that the nervous system and the automatic machines are fundamentally alike in that they are devices which make decisions on the basis of decisions they made in the past. Sounds kind of obvious. But what he did was, he demonstrated that the principles for operations of biological systems, of human beings, and lately for society are exactly the same. They all are exactly this system. The basic principle used in all these cases is this. And this is a very important diagram. Starting from your thermostat to your cars, to your computers, to your society, everything works on this principle. And what is the important thing? We are not going to spend all our time talking about this. What is the important thing is that at any particular time, what is happening is known through different kinds of sensors. You find out what's happening, and this is provided as the feedback. You know what you want to accomplish. What is your goal? So you need to know what is your goal, and you need to know what's your current situation. That means, in order to get to your goal, you have to know where you are at this moment. Okay? And based on this principle, all these systems are designed. Such a simple thing. Observe where you are, know where your goal is, and based on that, we start defining where you want to be. And when you start thinking about this, here we start thinking about, okay, you are observing something, you are sensing something, that means you have a lot of data. What do you do with that data? How do you convert this data to some actions? How do you make it actionable? And that's what you start doing. You take a lot of this data, convert it to information, and from information you create the knowledge. That's what is the process going on always through different kind of things in human society as well as in computers. On the other hand, if you are given a lot of knowledge, you take this knowledge, again you convert it to different information sources, and then you implement actions based on this. So there is a continuous cycle that keeps on going. That you are creating this knowledge, it's enriching the knowledge, based on this you do the actions, and these actions are changing the world, you are creating new data source. So this is what is going on. Another important thing, we all are interested in future. We want to predict, we want to find out what's going to happen tomorrow, what's going to happen 5 minutes from now, etc., etc. What was the first scientific field or technology that was developed to predict the future? Can anybody guess how many years ago people started developing this? This is the cover of a Scientific American that came out about a year ago, which was predict the future. They talked about all the machines there and how we predict the future now. Okay. So, any guess? Nobody knows when the first machine for prediction or first scientific field was invented for predicting the future. Now, when I saw the thing, please don't laugh. Okay. The first field was astrology. Now, why is it that nowadays we laugh at astrology? I will explain to you the reason in a minute. But none of us, possibly most of us in this room, don't believe in astrology. At least I always make fun of people who believe in astrology. But I consider that this was the first field. So the thing that happens is, how did we go from astrology to astronomical volumes of data? How do we create these things? And that's what becomes very interesting. Because we all think based on the different types of situations. There could be scarcity. Now suppose that there is a scarcity of data. Then what happens? Look at this. This is what happens. There are two scientists doing the logic. Everybody who went to the moon has eaten chicken. Okay. So, good grief, chicken makes you go to the moon. Logical, natural conclusion. Okay. That's what you can do if you are dealing with scarce or you don't have enough data. You are given these 2 points. What you do is, you fit a line and say, this is the new scientific principle. That's what was astrology. Astrology was developed thousands of years ago when there was no way to collect the data, there was no way to store the data. So what did people do? Because everybody is interested in predicting the future, they just took a few points or 2 points and fit the straight line through those. And that's how astrology came. And that's why it's not valid. Data was very insufficient. So what happens when you have lots of data, like the today's situation? Then what happens is, you have now abundance. So in fact, we are living in the society which is transforming in many, many aspects from scarcity to abundance. And when you do this, something else very interesting happens. Now you have all these points, you can either fit this line, you can put the second order curve, or you can go through and do all this kind of thing. So the problem that you start facing is, which one is really the most relevant solutions? Okay? So when you start putting together these things, then you also start identifying one of the very important thing that we all know and we all talk about, that correlation is not causality. Let's examine this, because this is a very important statement. Okay? When you start doing this, suppose that you observe that whenever I take this particular action, this thing happens. Now, there is some kind of correlation that you observed. That correlation results in some kind of insight for you. What you start doing is that based on that, you start forming hypotheses. Now, if you have lots of data, you look at that data, do the experiment design, do the testing, and suddenly you start finding out the causality. So you have this cycle going through this. So one of the most important thing for us to recognize when we are dealing with large volumes of data is that correlation is not causality, but correlation is definitely mother of causality. Correlation is going to start our analysis, correlation is going to lead us to causality. Yeah. So, I mentioned that we are living through this time of scarcity to abundance, different types of disruptions are going on. Until very recently, and possibly even today, you are a folder, whether it's in medical office or at some place. You just happen to, all your documents are put in a folder. But that thing is changing very fast. What is starting to happen is that now you are starting to become your own data. People are collecting all kind of data for you. You are collecting all kind of data about yourself. So you are becoming your own data. Now this transformation is very important. And this is the transformation that we want to talk about. Because, as most of you know here, that health is combination of genetics and the lifestyle. If lifestyle was not important, our doctors will not say do exercise, eat broccoli, don't smoke, don't drink alcohol. All the things that you like to do, doctors tell you not to do. So the reason is that our health is ultimately going to be a product of these two things. Okay? And this is extremely important thing because as Eric Topol started pointing out that we are going through real disruption time. There is old medicine and old medicine is getting transformed. How is it getting transformed? See this is very important thing to see. Particularly if you are from public health, this is the most important thing for you to see. That how health is getting transformed. The transforming agents for health are wireless sensors, imaging, information system, mobile connectivity, internet, social networking, computing power, data universe. Very interesting. This is all resulting in what he called creative disruption. And this creative disruption is resulting in new medicine. Okay? So let's see what can it be done. Unlike in the old medicine, where it was always that you will go to doctor and they will measure different parameters and they will talk about those things. Now you could be doing continuous monitoring of the data about a person. You will be building something that we will start talking in a minute, health persona. You could use all kind of predictive techniques because these predictive techniques can prevent different things, bad things happening to you. Okay? Before a heart attack takes place, it will tell you that there is going to be heart attack. In fact, we will talk about that before the heart attack takes place, for a particular person, there will be an ambulance stopping next to the person and saying, let's take you to hospital. Okay? So that kind of things can be done. You are doing all kind of quantitative measurements. And based on this, what is happening is people are realizing that behavior change is the holy grail of healthcare. How is that? Number one, you want to understand personal actions in context. This is very important. The second thing is you want to create personal good health habits in own ecosystem. You don't want to take people out of their ecosystem. Whatever they are doing, you want them to continue doing this. But at the same time, you want to start creating these things. What you want to do? You want to do contextual, pervasive feedback. You want to always try to do this. People are starting to design different gaming elements, different types of games that will start helping people do correct things. Okay? And finally, keep them connected, create social networks. There are all kinds of social networks, and this is nothing new. For the longest time, we had the Alcoholic Anonymous to Weight Watchers, and then cancer survivals networks and to all this kind of thing. So those things have been already happening. Now you can start making them happen lot more widely and lot more fast. So these things start happening. So what you start finding out is something very interesting. That what is happening is you have all kind of devices, and those devices, some of them measure environmental information, some of them will measure personal information, and these things can be combined so that all the data that is coming can be combined, integrated, analyzed, and then you can start interpreting it in order to decide how to take preventive actions, and you can start sending this information here so that we are continuously evaluating environmental context. If the environmental context is changing, the actions or advice will start changing. At the same time, you are continuously monitoring the person's context, where the person is, how the person's body is reacting to different things, and based on that you can start taking actions there. So these things start happening there. When you start thinking about this, you start realizing, so what is ultimately the fundamental problem? The fundamental problem is that you ultimately want to connect people to appropriate resources, and you want to do this effectively, efficiently, and promptly in given situations. Because we are dealing with public health type things today, how do we connect sick people to medical services? This becomes the most important challenge. Now, when we are trying to do this, we have to do this effectively, efficiently, and promptly, and do the situation. That means we have to detect all this kind of thing. In order to do this, we go to social networks. Social networks have become very popular. They have changed many aspects of our life. So we start thinking, how can we design new kind of social network or next generation social network that will connect not only people to people. That's what the current social networks do. You go to Facebook, they will connect you to your friends. But in addition to connecting to other people, can we start connecting people to all kind of things? And that's what is happening. That you take all kind of things, all kind of people, all kind of services, and you start connecting them. So you start connecting people and resources. They do all kind of processing to this, and you go through this. Effectively, what you start doing is the following thing. You start looking at all these sources. So you have everybody carrying the mobile phone, you have Internet of Things, different kinds of social network, data coming from NASA, data coming from different kind of businesses, data coming from hospitals, and all kind of sources. You collect all this data. Analyze this data and determine what kind of situations are evolving. We'll discuss in a second what the situations are. And based on this, you create the model of the situation. The situation will be very different at this location than in LA, than in New York, than in Mumbai, or any kind of places. So you start developing this. On the other hand, what you start doing is that you have these phones, but you have all kind of other personal sensors also. You start combining all those things, and based on this data, you start creating what we will consider a personal situation. We go through some steps that we will discuss in a second, but this personal situation tells you what is happening with the person. We take these things and start combining these two things. So we have two components that we are going to discuss in a minute. One thing we call Eventsoft. My student Siripen is leading that particular aspect of our project. Another thing is personal Eventsoft, with my other student Lale is dealing with that particular aspect. So we take these two things, combine them to identify what is needed and where the resources are. Feed all these needs and resources to a recommendation engine, and this recommendation engine goes and takes actions so that now you send the information to individuals as well as to different kinds of resources. Okay? So effectively what is happening is that you use all this data that is happening to identify what's happening where, what is available where. You use all this here to identify for each human being what kind of things they are going through, what will they need, whether it is emergency time, whether it is related to health time, whether it's good time to decide to have fun, and all this kind of thing will be decided, they will be connected through this. Okay? So this is what is going on here. What is computational situation? This is the mathematical description of this, or this is basically an actionable abstraction of spatiotemporal characteristics of different types of signal, because you have to start combining information that's coming from Facebook to information that's coming from NASA to information that's coming from Twitter, from your phone, GPS, and all kind of sources that you can imagine. And we will see some of that in a second. Okay? So this is what is going on. Okay? The question becomes is, how do we go from observations to situations? Suppose that we are living in the world and all kind of different events are taking place there. So all these events take place, we take a particular point. At this point, we try to get information from all these sources. We combine all this information that's coming for this particular point, and this point is mapped into this here. So effectively, based on everything that's happening in the world, which is being observed through all these mechanisms, is you are creating this kind of map. And this map represents what is happening all over the world. So once you have created this, you can start taking some important steps in solving the things. So in order to allow you to do all these things that I mentioned, there is no interesting or easy computational framework. So what we did was we developed this system that we call Eventsoft. Two students, Vivek Singh and Mingyan Gao, who graduated about a year ago, they started building this system. In this system, one of the important things is we assume that there are billions of data sources on the internet. You can go and get those data sources. You can put your own data sources, but in addition to that, there are all kinds of data sources available. We assume that we have to provide environment for selecting and combining appropriate sources to detect different kinds of situations. Okay? So an expert comes and says, I want to develop a system to prevent fires, or I want to develop a system to help people during the time of flood or during time of earthquake, or I want to help people who are suffering from asthma. Okay? So for all these kind of things, they will go and select what are the appropriate resources, how do we combine them, and by combining them you will get appropriate situations. Okay? By the time you have observed situation, many times it's too late. You have to start introducing predictive components so that you can find out what is going to happen 5 minutes from now. We saw this happen just a few months ago, or in the last 1 month. There was a hurricane first on the eastern coast of India, and then another one in Philippines. In Indian hurricane, they could get the information and they could warn people about 5 minutes before it really hit the coast. In Philippines, they could not do. Result, in Indian hurricane, which was about the same intensity, slightly weaker, but only about 10 to 15 people died. In Philippines, several thousand people died. Okay? So that idea to provide this predictive information is extremely important. This should be able to interact with different types of users. Decision makers should be able to decide what to do, so do individuals. So how do we provide this environment? This is what Eventsoft looks like. In the Eventsoft, what you do is, here in this area, you can start selecting. By the way, Eventsoft was inspired by Photoshop, and because Photoshop was done by my student in my lab at University of Michigan. So Mingyan Gao and Vivek Singh thought that we want to give equally easy environment to process different types of data, not just images. Okay? And combine those things to detect what kind of events are taking place, which will result into finding out what the situations are. Okay? So this is what you start doing. Here you select different type of things. Here you start selecting different types of operators, and you want to build in sequence different things, so you start doing this. The results will be displayed here. You can see some more results here. You can take some particular actions and this kind of thing. So in order to give you a feel of what it works, we have applied it to many different applications. But to just give you the idea, let's consider a simple disaster management type of application. In disaster management, you are getting this data from different sources. Governmental agencies provide you data, resources and historic data, what has been going on, where the shelters are available, what kind of things are available where, Internet of Things, where different things are there, where is the ambulance or where different things are, different social networks and NASA-like sources. take all this kind of thing, combine this, and there will be a user who will be interacting with this. In order to do this, we take this whole background, replace it with this kind of thing, Eventsoft. In order to do this, let's see how it was applied for Thai flood. Siripen had just joined our group that time, and there was this big Thai flood there. So Siripen said, I will be convinced that I should be working on this project only if you can help Thai flood people, because he's from Thailand and he's from Bangkok, that's where the flood was. So what did they do? They started building the system. They identify what kind of sources are available, starting from Twitter to flood level to where the shelters are available, and they started applying different types of operators. I will not go through the details, but once you combine this, this is what the situation started looking. Red are the areas where the flood was really bad, yellow was tolerable, and green was wonderful. Okay? So now once you have this kind of thing, suppose that you want to now convert this to a decision-making system. How do you make it a decision-making system? You do a simple thing. You convert this to decide what kind of action, and this is again the expert is deciding how you want to put the actions, but effectively based on the actions, now whenever somebody tweets, the system automatically started looking at the tweet, they found where the tweet is coming from and what should this person do. So we implemented a system that automatically started responding to the tweets that were coming from different people. Now these tweets, it is very important to know that this was no government organization or nothing. Just because of simple Twitter, lots of people started retweeting those. That means they started finding this thing useful. Now this was done some time ago, so it was the Twitter. We'll replace that Twitter with something else. But the second problem that I want to spend more time discussing with you here is related to asthma and allergies. Okay? We started looking at this, and I must confess here that our knowledge about allergy and asthma is not very deep. Okay? So what we started doing is went on the web and other sources and started finding out some reasons why should we be dealing with asthma and allergy. Vivek was excited about allergy and asthma. He convinced me that we should be looking at it by using this kind of arguments. That there are 26 million Americans and 300 million people worldwide who suffer from asthma. Very good number. A lot of people are there. Asthma is underdiagnosed and undertreated. This number 300 million will possibly be much higher than 300 million. It may be 500 or 600 million. Because in the developing countries, they just don't know that they have asthma. Okay? So, other reason to start looking at this was these two. The causes of asthma are not completely understood. Nobody knows very clearly that this causes this thing. So, that means the disease models are not clearly known. The second thing is lifestyle changes help as much as medication. There is some medication available, but doctors emphasize that in order to really deal with asthma, your lifestyle is as important or possibly more important than medication is. And this fits in extremely well, as you will see in the next few minutes. These two things are something that modern technology can help in a big way. And that's what we decided to start doing. So, asthma triggers. Why does asthma happen? Because of lots of these reasons. There could be some indoor allergens, there could be some outdoor things, different kinds of chemicals, smoke, and air pollution. Air pollution is becoming particularly important because lots of countries are developing. They are developing very fast, and they are creating the big problem. There was recently an article that said that in Beijing, the air pollution is so bad that just if you live in Beijing, that means you are losing your life expectancy by 5 years. You lose 5 years of your life just by living in Beijing. That's the air quality thing. Okay? So how can we start helping some of these people who suffer from this kind of things? So for that, we started building a system. Again, we used Eventsoft, and what we started doing was the same kind of thing. We started using the Twitter data in this particular case. We started using air pollution
air quality, and these things. We started combining all these things, and based on this, for United States, and this is being done every 5 minutes. So this is not that once it is done and that's over. This will be updated every 5 minutes. So you are looking at all the data that's coming from these sources, you are combining this, and you are coming up with this. Now if somebody is thinking of going for jogging, for that person, it is very important to know if the person suffers from allergies or asthma, whether this person should go jogging or not. So if this person contacted the system can tell that, okay, you are in this area, don't go jogging here, but if you drive a little bit there, you can go jogging. Similarly, if I am planning a trip or something, my system can tell me that you are going to be going there. If the prediction is built into this, that the air quality is going to be really bad, take this medication with you or take this preventive action. So this is what we started again implementing. This is again we did with Twitter and implemented the system. So this is helped people, but one thing that this system did not have in our first generation was this, that everyone's respiratory health is different. It's very subjective. And this is for both reasons, genetics as well as lifestyle. So because of that, now how do we find out who can be helped how? Yeah? So how do we deal with these different people? And that's where this idea comes in. That, as I mentioned in the beginning, that where are we using all this big data? Where are we using all the machine learning techniques and all this kind of thing? They are being used currently to determine your personality based on how you use internet, with whom you interact on Facebook and things like that, and to show you the advertisements. Can we go beyond that? Can we start determining the persona in different aspects of the person? Particularly, can we take care of health? And if you want to do this, it's very easy now, because we have all these data streams coming in. You could be using different kinds of wearable sensors, or even if you are not using, your smartphones have enough number of sensors. And the number of sensors in smartphones is continuously increasing. Okay? So because of all those sensors, what's going to happen is that you have now different types of streams that are being fed, and analyzing those streams, you can start building a persona. The interesting thing that has happened in the last few years is this. There has been an explosion of fitness devices. In 2009, there were only these few. 2012, you have all these devices coming in. But more interestingly, in 2013, there has been a complete explosion. There are something like 250 new companies that are developing these devices. So how do we develop insights from these devices? You have all this data coming from these things. Each system will allow you to look at the data. But how do you start combining all this data? Because your persona is combination of these things. From there, how do you start building these things? How do we start making this persona so that human beings can act for themselves or for others? And in order to do this, this is the idea that we started pursuing. And the idea is that you have different kinds of logical sensors, you have fitness tracking sensors, either externally that you are wearing or on your phone. You have physiological sensors that could be attached to your body, that could be attached to your inhaler and all this kind of thing that is giving some information. You take these things and you convert these things, and we'll see in a second, to something called life events. That how all these things can be combined to life event, but also what kind of food events are taking place, kinetic event or physiological events taking place. So effectively you start classifying these different events. And you take these life events and start creating a database, if you want to call it a warehouse, of what we started calling personical, which stands for personal chronicle. It is creating automatically a chronicle of your life. You are not taking any particular action, the system is automatically starting to create it. Can we start combining this data with all these event data to do all kind of data mining, machine learning techniques to build the health persona. In order to do this, what you realize is that this correlation and all this analysis should not be based on time. Time is important. But what's really important are the events. Whenever I eat this thing, I get acidity. Whenever I overdo this exercise, this particular bad reaction takes place. So you start relating this kind of things there. Okay? So in order to do this, there has been a community that has been creating life logs, collecting all kind of information. They came up with ontology. Don't worry about this, but this ontology tells you what kind of activity you could be involved in. Depending on the application that you are trying to develop, whether it is related to asthma, whether it is related to any other disease, you can come up with this ontology. Use this ontology and you start doing something like this, that you have now all these kind of different types of events that are taking place. These are all based on the time. So you have all these events taking place. You take these and combine this with the life events. In other words, what you are really starting to do is to create a personical. These are the real devices that we are now using. Moose sits on your iPhone or on Android. It gives you all this kind of information. What is happening with you? Personal calendar, whether it could be Google Calendar or any kind of calendar, has some information about you. Activity level, things like Nike Fuel or accelerometer in your phone, start giving you all that kind of information. You take this, combine this with Foursquare that starts taking this, okay, and you can start creating personical, which will start then looking like this. That at this time you are at home, then you are driving, you are walking, meeting, etc. And for all these things you will have more important information. For example, here it says eating dinner and Foursquare says at University Club. So you know Lale that they ate at University Club. Okay? So this is the kind of information that is automatically created. Now there are lots of personal or privacy implications about those things, but this data is your own data. And we can talk about privacy after the talk, because in this particular case, privacy should not be that big a concern, because you can control your data. And there are many techniques being developed there. But the important thing is now you have all this kind of thing. We have already started looking at the complete architecture for personal Eventsoft. Without going through all kind of details, you start looking at this and start seeing that what kind of event streams are being generated here, how this data is going, and you are starting to develop personical here. This predicted data analysis goes to recommendation and goes to the phone. What you find very interesting is that phone becomes an important source for input data, as well as it becomes important source for all kind of sensory data. It also becomes a source for giving the information and on which people can act. Okay? So this, we have started implementing this. Parul sitting there is implementing this so that you can start combining data coming from Moose, from Nike, and from Google Calendar. And you can take this and start combining this to get the data that starts looking like this personical. Now in this personical, effectively what you are seeing here is a very small interval from the time here, but you can start looking at this, and this is showing all the events taking place over time period. That means now the system has all this information about you. So what can you start doing with this? Suppose that you want to find out what are the things that trigger my asthma. All that you need to do is to look at the personical and to look at the activity stream. Okay? So you take these things, this is now giving you a personical, this is activity stream. Mengfen there is working on applying machine learning techniques to this kind of data, but in this particular case the idea is very simple. All that you need to do is that this is what is happening, that red represents severe asthma attack in this, and this is high or very high activity level. You can combine this and you can see when is that happening, and you can conclude exercise triggers my asthma or heavy exercise triggers my asthma. Very simple conclusion that can be drawn. But if you want to go further, you will have to start looking at this personical, and you will have to start analyzing that whenever you do this thing, after some time this particular action takes place. Now, how do you do all this analysis? There are different correlation and co-occurrence based techniques that will start giving you insight, but then you can start building the models like this. So this is what the personical based things will start giving you. We are also building an application that Jordan here is trying to do, is to put together telephone or smartphone based thing. So effectively we intend to launch this UCI allergy asthma application in January, so that by 15th of January you should be able to get it on your smartphone, and you should be able to view all the information, and the system will start warning you depending on where you are, what kind of things you should be doing. Our goal is that we want to launch this system and get several thousand users in February, so that we can start running experiments to understand exactly how people behave in different kinds of situations, and what kind of things we should be doing. Effectively what we want to do is, we want to go from this persona, so we are building this individual person, how can this help whole society? For that, we saw that this kind of situation can be built. You can classify that situation, you can go to different countries, different people, you apply this situation, so that now you start looking at this data from different sources, and you can start doing the disease modeling. So you can start now collecting all kind of data, in place of relying on 2 people or 5 people or very small sample size. You start collecting data from all kind of sources in realistic situations, and you start understanding how this disease takes place. On a personal note, once I had cancer, something like 10 years ago, and when they decided to give me particular kind of chemotherapy, they were going to give me Fuchs-5 and cisplatin. I asked my doctor, why are you giving me this as against other things? The answer was, because it works. I asked them how it works. They say, we don't know how it works. We only know that on the number of experiments that were done in Ireland or for a particular group, it was effective on about 53% cases. And that was the best percentage. So they are going to give me that. It was lucky that I was one of those 53%, so I am standing in front of you. But just think about this. This is the status of disease modeling. If we want to do much better disease modeling, all that we need to do is to start collecting this data. And now we have tools to start collecting this kind of data. So this is what we can do. That means effectively, what is going to start happening is that we can go, whatever disease models we have, we can use all kind of personal data to build better disease models, and these better disease models can be used to provide better quality of life. And because of this, there will be a continuous feedback between the two things. So we are building a virtuous loop that can start helping this. And in all these kind of things, one of the most important things that happens is that we are really introducing mobile phone as the now 24/7 recording stethoscope. What was the stethoscope all about? It was to understand what is going on inside the body of a person. Now we have this device that is continuously measuring. It's not only when you go to the doctor and doctor is interpreting this. This can be done all the time. That means finally we are entering 21st century. And this is what is starting to happen. So how can we take this for global health? There are about 1.3 billion people today who are using smartphones. They can start using this. There are another 3.8 billion people who are using feature phones, and within next 2 years, by the time we develop these technologies, they will all be using smartphones. And the last group of people, many of them will be starting to migrate upwards in terms of their connectivity. That means all these people will be using the devices, and they will all be connected. They can all be collecting all this information. So we can help all these people. In fact, this is the only way possibly we can help in many of the developing countries to deal with many different kinds of diseases and many different kinds of problems there. So with this, what is the current status of our system? You can see live Eventsoft demo here. This system now is being used by many different people. For example, National Institute of Communication Technology in Japan and our own NIST, they are working on cyber physical cloud computing project, and Eventsoft or this system has become a very important component of that. So they are working with us in this. There is a project in Sri Lanka, but this project is being done in Australia to help farmers in Sri Lanka decide what kind of fertilizer they should give, what kind of crop they should be doing, when to take particular kind of actions by using the similar kind of technology. We are converting our current version of Eventsoft to open source version, and a company called HCL is helping us do this thing. We are working with Tsinghua University to do, they have 300,000 taxi drivers for whom they have last 3 years complete data, every day what did they do. Can we start using that to understand where are the bottlenecks, what kind of things are going on using this kind of thing. So this is what the different kinds of things that we are doing. It would be great if I can find some of you to work with us in allergy, asthma or any of the health related problems. Thank you very much.